It was supposed to be a celebration. July 17th, 1981. The Grand Hyatt Regency Hotel in Kansas City was alive with music, the air thick with laughter, and hundreds of people swaying to the rhythm of the orchestra in the shining glass atrium. Couples danced beneath the walkways, suspended high above, shining ribbons of steel and concrete that framed the night's energy. But at 7:05 p.m., in less than 5 seconds, that joy turned into horror. The suspended walkways, symbols of the hotel's modern elegance, tore loose and fell, one atop the other, crushing the crowd below. 114 lives were lost. 200 more were injured. It remains one of the deadliest structural failures in American history. What brought them down wasn't an earthquake or an explosion. It was a drawing change, a seemingly minor design revision buried deep within a set of engineering documents, so small it might have escaped notice entirely, but it did not escape consequence. That night, the Hyatt Regency's atrium became a silent classroom in structural failure, ethics, and the cost of human trust. To understand what went wrong, we have to go back to the beginning, to a time when Kansas City was reinventing itself. In the late 1970s, the city's downtown skyline was dotted with new ambitions. The Hyatt Regency project, designed by PBNDML architects and built by Crown Center Redevelopment Corporation, was meant to be its crown jewel. 40 stories of modern glass and concrete, completed by a vast atrium that rose more than 100 feet. It was to be an engineering marvel, a place where architecture met spectacle. The centerpiece was the multi-level suspended walkway system, connecting the hotel's north and south wings across the atrium. Each walkway hung from steel rods anchored into the roof structure, floating elegantly above the lobby. The uppermost walkway was aligned directly above the second, with the third further back. Guests could look down through glass and steel at the bustle below. It looked effortless, graceful even, but the beauty was deceptive. Every gram of weight, every step across that span, depended entirely on how those rods were connected. In design, elegance is never free. In the original engineering drawings, the concept was simple and safe. Continuous steel hanger rods would descend from the roof, passing through the upper walkway and continuing down to support the second. The load from both walkways would transfer through a single rod to the roof, a clean, predictable load path. It was sound in principle but difficult in practice. During fabrication, the contractor raised a problem. Threading those long rods through multiple levels during assembly would be challenging, especially given the tight tolerances. They proposed a change: 2 separate rods instead of one continuous piece. The upper walkway would hang from the roof as before, but the second would hang from the first, using a second set of rods connected to the underside of the upper beams. On paper, it seemed minor. The drawings were redrafted, approved, and filed. The difference was only in the connection detail, just a few lines, but structurally it was catastrophic. That small revision doubled the load on the upper walkway's connection points. Instead of each rod supporting the weight of a single walkway, it now carried both. The upper connections were never designed for that. Yet the change passed through engineering review without recalculation or stress analysis. The seeds of disaster had been drawn in ink months before anyone stepped foot inside the hotel. Construction continued through 1979 and 1980. As the massive atrium took shape, the steel walkways gleamed with promise. Few questioned their safety. Inspections came and went. Nothing seemed amiss. The Hyatt Regency opened in July 1980 to great fanfare, a symbol of modern Kansas City's rebirth. And for the first year, it delivered. Guests marveled at the soaring lobby, where sunlight poured through skylights onto polished marble floors. On Friday nights, the hotel hosted the tea dances, local traditions revived for the modern era. Families gathered, couples danced, and retirees reminisced to the swing of a live band. On July 17, 1981, roughly 1,600 people filled the atrium. Dozens stood on the second and fourth floor walkways for a better view of the festivities below. None of them knew the metal beneath their feet was under silent stress, its welded connections already deformed from fatigue and overloading. Then came the sound. A sharp, metallic crack, followed by a deafening rumble. Eyewitnesses described it as a thunderclap from inside the building. The fourth floor walkway dropped first, tearing free from its supports. In a fraction of a second, it struck the second floor walkway directly beneath it. Together, the two masses, each weighing more than 60,000 pounds, fell into the crowded atrium. The impact was instant and absolute. In one horrifying cascade, lives, laughter, and steel became indistinguishable. Rescue crews arrived within minutes, but the scene was apocalyptic. Concrete dust hung in the air like fog. Survivors trapped beneath the wreckage cried out for help. Others were silent. Emergency workers crawled through twisted beams and shattered glass, cutting through steel with torches. The hotel's sprinkler system had ruptured, flooding the atrium as rescuers waded through rising water to reach the injured. It took 9 hours to remove all victims. When the final count came, 114 were dead. The youngest was 11, the oldest was 70. The nation demanded answers. Within weeks, the National Bureau of Standards launched one of the most thorough engineering investigations in US history. They began by reconstructing the walkway connections piece by piece. It didn't take long to find the fatal error. The revised hanger rod detail, approved months earlier, had never been recalculated. What appeared as a fabrication convenience had, in effect, doubled the load on the upper box beam connection. The welds and bolts were never intended to bear that force. In testing, investigators found that the connections failed at only 30% of the required load capacity. In other words, the design had been destined to fail the moment it was built. The official report concluded that the cause of the collapse was a serious structural deficiency in the box beam hanger rod connection, resulting from a design change not properly reviewed by the engineering firm. The language was clinical, but beneath it lay a human tragedy. The fallout was swift and far-reaching. The engineering firm responsible for the design, GCE International, saw its senior engineers stripped of their licenses. The Missouri Board of Architects, professional engineers, and land surveyors cited gross negligence and misconduct. Civil suits followed, resulting in one of the largest settlements in US history at the time, nearly $140 million. But for many, justice felt hollow. No one had set out to cut corners. There was no conspiracy, no malice. The Hyatt collapse wasn't born of greed, it was born of assumption. Each team had believed the other had checked the numbers. Each department trusted that someone else had verified the drawings. The lesson was brutally simple. In engineering, trust is not a substitute for verification. The disaster reshaped the field of structural engineering in America. New standards were written for peer review, documentation, and design change control. Building codes were updated to ensure independent verification of load-bearing revisions. Universities began teaching the Hyatt case as a defining lesson in engineering ethics. It became required reading in classrooms across the world. The story of those two walkways became more than a tragedy. It became a moral architecture lesson that every bolt and beam carries not just weight, but responsibility. Today, if you visit the site, you'll find the hotel still standing, rebuilt, renamed, and redesigned. The atrium is smaller, quieter. A memorial outside honors the 114 who lost their lives that summer evening. The plaque bears a simple message: in memory of those who danced. It is a reminder that behind every structural drawing lies human trust in calculation, in craftsmanship, and in care. The Hyatt Regency collapse taught us that when that trust breaks, structures and lives fall together. In the end, it wasn't the failure of steel or welds that doomed the Hyatt Regency. It was the failure of communication. A single change, passed unchallenged, untested, and unseen, revealed the fragility of the systems meant to protect us. Engineering, at its heart, is a moral discipline, a promise that what we design will hold. And on that night in Kansas City, that promise broke. The sound it made still echoes across every drafting table and every code revision written since. Because the Hyatt collapse wasn't just a tragedy, it was a warning. And warnings, if remembered, can save lives.